Hi everyone, these are our practice test matter midterm answers. And our first question, Johnny and Marie are arguing over their lab results from their balance. Johnny says that the balance reads exactly 1.44 grams and Marie says it reads exactly 1.46 grams. Who is right? Well, this goes to our activity we did on What's My Mass when we found out that the same thing weighed different on different scales. And you'll notice both of them use the term exactly. So the first one is neither of them are right because both of them said exact. And the whole point of that was scales are not exact. They have error. Now, if you would have put both of the numbers are so close that they could be right because of scale error, I would have also taken that as a correct answer. That would have showed me that you understood that scales are not giving you exact measurements and that they have error. So I would have taken either neither of them are right because they're not exact, or both of them could be right because they're so close together. Our next question. Johnny was watching a balance that suddenly went down on one side. He exclaimed to his partner how amazing it was that the balance could move with nothing on it. What should Johnny's partner tell him? Well, this question goes to our activity that we did of when is something something, and we found out that moving a balance is kind of what defines whether something has mass or not. And so you should say, you're wrong. If a balance moves, it means that there is mass. And if there is mass, it means that it is something. So if a balance moves, you know you have something because you know you have mass. Next one. This one goes with our activity, what do you remember from 6th grade, and also was covered in our reading on the periodic table. It says, Johnny was playing with some Legos, pretending they were the smallest pieces, chemical pieces of matter. He said that he would put some of the Legos together to form an atom. What should you say to Johnny? Well, the thing you should say to Johnny is that it's not correct because atoms are the smallest piece of chemical matter. And when they go together, they make molecules. So things don't go together chemically to make atoms. Atoms go together to make molecules. Our next question. When is volume not something? Well, volume's not something when it's a vacuum. This goes to our syringes activity we did when we drew the syringe back and saw that we made a space, and because the syringe would go back and take up that whole space, there was nothing in it to block the syringe, and we'd made a vacuum. So a volume with nothing in it is a vacuum. And then our final question on this first page. And then our final question on this first page is if you could add a proton to nitrogen, what would happen? And notice it says you need to look at a periodic table to answer this. So this goes to the reading we did on the periodic table. And when we looked at a periodic table, we saw that all of the elements had numbers. And hydrogen is up here at number 1, and it's not number 1 because it was found first. It's number 1 because it has 1 proton. Lithium is number 3 because it has 3 protons. Beryllium is 4 because it has 4 protons. So protons are the identity element of an element. So if we come over here, and it says we have nitrogen with 7 protons. If we add a proton to nitrogen, well, then all of a sudden it's got 8 protons, which turns it into oxygen. And so the correct answer is you would turn it into oxygen. Question 6. Name 3 parts that make up an atom, tell where each one is located. This again is in our reading we did on the periodic table. And the 3 basic parts of an atom are protons, neutrons, and electrons. Protons and neutrons are in the nucleus. Electrons are outside the nucleus. If you would have just wrote these 3 words and drawn me this little picture, I would have given you full credit for that as well, where you're drawing the protons and neutrons in the nucleus, and you have this little minus sign out here for the electron. And I would have taken that as being full credit. And then our final one, draw a picture of a syringe that will have the plunger go in if you let it go. Notice it says showing the air is crucial in this model. This is actually the same exact drawing that you had for your 3rd drawing in our syringes lab. And it should look like this. And what we're showing in here, the reason it's so crucial is because the air inside the syringe is stretched compared to the air outside of the syringe, meaning this is lower pressure air than this. And remember, air does not like being stretched or squeezed. It likes being neutral, and so the air out here is going to push to get in there, and it'll push right on this plunger until the plunger goes in. So again, your drawing needs to look like that. You need to show the air out here closer together than the air in here. Hope this has been helpful for everybody for tomorrow's test.